In this question, a scientist wants to predict the change in Gibbs free energy, delta G naught reaction, for a fictional reaction involving fictional elements with the symbol A, Z, R, and Q at 298 Kelvin. Our first step is to balance our equation. I'm not going to show how to do that here. I'm going to assume you're already confident with balancing equations. If you need more practice, go back to the balancing equations unit. So to balance this equation, I need 6 of this, 1 of this, 3 of this, and 2 of this. Okay, so in this question, we're provided with Gibbs free energy of formation for each of our compounds in our reaction. That's the Gibbs free energy change when a compound is made from its constituent components. We can use this equation here for Gibbs free energy of reaction in terms of the Gibbs free energies of formation. So here we can see the change in Gibbs free energy for a reaction is equal to the sum of the change in Gibbs free energy of formation of the products minus the sum of the change in Gibbs free energy of formation of the reactants. So first, let's find the total Gibbs free energy of formation of the reactants. So I can see in my reactants, I've got 6 sets of RQ, plus I have 1 set of A2Z3. So if we substitute in our Gibbs free energy of formation for those, we've got 6 sets of RQ. For RQ, it's negative 41.6, plus 1 set of A2Z3, which has a Gibbs free energy of formation of negative 135.4. So if we put that all into our calculator, we're going to get out a value for our total free energy of formation of the reactants of negative 385. We can go ahead and test that out over here. Awesome. Then for our products. Here in our products, we've got 3 sets of R2Z, plus we've got 2 sets of A2Q3. So 3 sets of R2Z, the Gibbs free energy of formation for R2Z is negative 79. Plus we've got 2 sets of A2Q3, which has a Gibbs free energy of formation of negative 97.8. So if we put that all into our calculator, that gets us out a Gibbs free energy of formation of our products of negative 432.6. So we can go ahead and fill that in here. Awesome, okay. So now we can substitute those into our delta G of reaction equation. So for our products, we had negative 432.6. For our reactants, we had negative 385. So if we put that into our calculator, that gets us out a delta G naught of reaction of negative 47.6 kilojoules per mole. So we can go ahead and fill that in here. Awesome. So same as the previous skills, we're now figuring out, is our reaction thermodynamically favorable or unfavorable? And is it spontaneous or non-spontaneous in the forwards direction? Since our delta G naught of reaction is less than 0, we have a favorable reaction that will be spontaneous. Much like you use the enthalpy change of formation or standard molar entropy to find the enthalpy change of reaction or the entropy change of reaction, in this skill, we're using the Gibbs free energy of formation to figure out our Gibbs free energy change of reaction. So all we need to do is first balance our equation, then we're going to be adding up our total Gibbs free energy of formation for all our reactants and products using our coefficients from our chemical equation. Then we're going to take the Gibbs free energy of formation of the products and subtract the Gibbs free energy of formation of the reactants to get our change in Gibbs free energy for the reaction. If it's less than 0, our reaction is thermodynamically favorable and spontaneous. If it's greater than 0, our reaction is not favorable and it's non-spontaneous.